Maybe you should come. How about the
Okay.
essentially with it? CD. You should go. Maybe you can get one of those urban transport.
It's just been upgraded to I'm not struggling. You go to the hospital.
You're okay. Technicals out there.
We can't, which is why we need to give them an alternative.
That's right. They've been tracking the Pride since this morning. We're about to deploy units.
There's your alternative.
Okay.
Hello friends, very good morning to all of you.
Good morning, sir.
Morning,
Morning, sir.
morning.
Good morning.
Good morning. Okay, let's continue with today's class. So I hope all of you have clarity on the topic we are discussing. Ritik, I'm not the admin, so I can't allow you to record because like admin is universal group. You have to ask the management about the recording of the class. I'm just the host. Okay, so please check with the management. Is it clear to everyone? I think it is recorded. It has been recorded actually. I just noticed it has been recorded. You just ask the management about it. Okay. So in the previous class, we have covered solar system. And please check your NCERT, all of you. Class 6th NCERT, I'm showing. The class 6th NCERT, Earth in the solar system. That is the chapter name. Okay. If you're wondering which NCERT, class 6th NCERT. And also I'm going to share you the link also in case if you're wondering where to download and all. If you don't have the hard copy. Okay. So please check your see, I'm showing you the class 6th. See, this is the chapter we have covered. Earth in the solar system. So already you know many things about Earth, you know many things about solar system. I have covered extra. Means like some of the topics which are not there in CRT also have covered. Okay. That is because it's very important to know extra information now. So slowly we'll increase the information. Like universe, I will discuss one day. Okay, I'll tell you about the star cycle. Okay. So many things I'm going to cover later. Okay. So I'm sending you the link also. All those students who don't know where to download the NCERT, you can check it out here. So today's open book test is only solar system. The first chapter of class 6. Class 6. Class 6 NCERT I've covered. Okay, I have sent the link also. Please check it out. Please check the link. And also, I'm sharing you the PDF also. All of you, please check the PDF. Any doubt? Please let me know if you have any doubt. Okay, let's continue now. Okay, just check out the NCERT. Already we have covered all these places. Okay, so we'll be discussing about moon. Don't worry. Amvasya and all, I'll be discussing that about moon. So for now, all of you remember the stars, about our satellite. Already I told you how the moon was formed and all. North Star, Polaris star, we have seen. Okay, constellation is group of stars and a pattern, I told you. Okay, constellation. See the word constellation. Already I have discussed this. Pole star we have discussed. Planets we have discussed. Sun and all the 8 planets we have discussed. You can see the data is given here also in your book. In your NCERT also, it is given here. Extra I have covered asteroids, dwarf planets, and all I have covered. See, sun I have covered. Please remember this. Okay, all the orbits, Earth, geoid shape, moon, correct? Asteroids, meteoroids. So you should answer these questions now. So which planet is known as Earth's twin planet? You have to answer. Which is the third nearest planet to sun? All the planets move around the sun in. Please answer this. Pole star indicates the direction to the. Please answer. Okay. These are simple questions that you can answer. Also answer these questions. Theory questions. Okay. Very easy and very important also. Asteroids are found between the orbits of. Please answer this. Also you do the fill in the blanks. Shall I go to the next chapter now? So hope all of you will answer, because yesterday itself I was okay. Yesterday I have covered all the questions also. So now we can go to the next chapter. Next chapter is about globe, latitudes and longitudes. So give the heading as globe, latitudes and longitudes. Remember in the first class I told you globes are small scale model of the earth. It is a 3-dimensional model of the earth. How many of you remember the definition? Raise your hand, please. What are globe? They are 3-dimensional representation of the earth's surface. Globes are 3-dimension. Three-dimensional representation of the earth's surface. It's right. Globes are 3-dimensional representation of the earth's surface. Three-dimensional representation of the earth. Can I also say it is a small scale model of the earth? How many of you agree with the definition? Raise your hand. Small scale model of the earth. All of you are able to see the screen. I'm showing you the NCERT class 6 chapter 2. Please raise your hand if you can see the screen. Okay. Yes. So all of you remember the definition I wrote. Small scale model of the earth. So just like when you go to a place, let's say they're building a apartment, they'll show you the small photo or model. No, before construction itself, they'll show you the model. Okay, after construction, the building will look like this. Like if you go to a dam, they'll show you a model of the dam. How many of you have seen a model of a dam or a reactor? Small model will be there. Okay, then you can go and see the big one, something like that. So you have seen the car models like Mercedes car model and all. You have seen the small models. You have seen. Those are small scale model of the objects. So just like that, globe is a small scale model of the Earth. So all of you know globe. So if I cut open the globe, if I open the globe, I'll get the map. Maps are two-dimensional representation of the Earth's surface. Maps are two-dimensional. See, on the globe, we have some imaginary lines. Have you noticed some lines running east, west, and north, south? There's some lines, imaginary lines. Okay, so those are called as latitudes and longitudes. The latitudes and longitudes are basically imaginary. Please check it out. Latitudes and longitudes are imaginary lines. So why are we studying this? They give us angular measurements on the Earth's surface. They help us locate a place, identify a place. We can calculate the distance of a place from a reference point. Okay, like that, latitudes and longitudes have a lot of benefits, have a lot of advantages. So as a result, so first write the first advantage, all of you. So latitudes and longitudes are imaginary lines. Imaginary lines, they help us in locating a place by giving angular measurement of a place. Please take first one. First advantage is locating a place. You can locate any place on Earth because they give us angular measurements of a place. Please, right? They give us angular measurements of a place. Where is that exactly located on the Earth? We can locate. First advantage. Second advantage, by understanding latitudes and longitudes, we can also locate a person also. Today, we all carry our phones. Correct? Locate a person. The phone today acts as a GPS. How many of you heard of GPS, Global Positioning System? GPS. GPS. Using GPS, we can locate a person also. You don't have to carry a separate device. Your phone itself acts as a GPS. So have you noticed the option called location sharing in Gmail? How many of you have activated that location sharing? Go to Google Maps, and there is the option called location sharing. Okay. Miniature means small. So Earth is very huge. The smaller version of the Earth is globe. Miniature. Miniature means small. Okay. Miniature means small. So all of you have noticed the location sharing option. Okay. So please notice that if you use that, and if you share your location with your parents or friends, they can notice your real-time location, where you are, where you have been. Those things they can see. Okay. So locating a person. Today, like crime against women and children have increased. Correct. So in order to keep their kids safe, parents are using this now. We can locate a person using GPS, Global Positioning System. Please write GPS, Global Positioning System. Using this, we can locate any person now. Okay. Third, if you understand latitudes and longitude, we can understand the topic seasons. What are the various seasons we have? Summer, winter, spring, fall. Correct? You might have heard of this. Correct? We can understand various seasons, weather and climatic aspects of the Earth. Seasons. I'm telling you the importance of these topics. If you understand this, we'll know why we should study this. You'll get to know the importance of these topics. By knowing the importance, we'll get the interest, because generating the interest is very important. Okay, before we start any chapter. So I'm trying to do that. So when we understand these two topics, you'll know how to locate a place, how to locate a person on using GPS, what are the different seasons. All this you'll understand after the end of the chapter. If you understand this topic, you'll understand time zones. Please write time zones. How do we calculate time? Correct? On a day-to-day basis, how we calculate time? Today, different countries are in different time zone. Okay, different time zone. They help us in identifying the time zone also. Fourth advantage. Fourth. Fifth. Right, fifth. Navigation. How many of you have used navigation? Google navigation? Yes. Correct. If you are new to a place, if you want to go somewhere, what you do, you type the destination and the destination will be shown on the map. You can use the direction. Correct. You can start navigating from your point to the destination. So navigation is a very useful tool which helps us in saving time, fuel, money. How many of you agree? Navigation helps us in saving time, fuel, and money. Have you ever noticed, like, using the navigation, you can reach fast, less fuel is consumed. Also, money is saved. Money is saved. We have all types of navigation today. Land-based. We have land-based navigation, air-based navigation. Pilots also use this. Water-based navigation. Water-based navigation. Ships, planes, correct, land-based automobiles. All of them use navigation today. Okay. Navigation is used by all modes of transport. Even the pilots you might have seen, they have something called autopilot option. How many of you have heard of this autopilot option? So as soon as the plane takes off, so they'll switch on the autopilot. So they'll know the destination. It is already fed into the system. The plane will go in that direction. Okay, when they want to land, they'll come and land the plane. Okay, like that. Navigation. Ships use that. No. Ships use navigation. Automobiles use navigation. Okay, please write. Fifth, navigation. Okay, we have something called, we have India's own navigation system called Navik. How many of you heard of Navik? Navik. It consists of 7 satellites. 7 satellites. All of them have been launched. All of them have been launched. Earlier, it was called as Indian Regional Navigational Satellite System. Indian Regional Navigational Satellite System. Indian Regional Navigational Satellite System is the older name. Older name. Indian Regional Navigational Satellite System. Series of 7 satellites. Okay. Used for navigation. So today it's called as Navik. Navik. Underline Navik. Navik. Okay. Sixth application. Please write sixth. To launch satellites. To launch a satellite. Let's say we are launching a satellite over a particular place. We need to be over a particular place. Let's say we are launching a satellite for SAARC countries. For all the SAARC countries, it has to be above SAARC nations. We have 8 SAARC nations. The satellite will be providing services to all the 8 countries of the SAARC. So the satellite will be located over somewhere over India. Like we are launching a satellite for African countries, let's say. So it should be over Africa. So using latitude and longitude, we can fix the satellite in the sky. How many of you understood this? Using the latitude and longitude, we can fix the satellite in its place. Okay. So it can be controlled from the ground station. We have a ground station like master control facility in Hassan. ISRO's master control facility is in Hassan, Karnataka, from where we control the satellites in the sky. Okay, satellites can also be placed in the orbit. We can place the satellite in the orbit using this concept. Okay, seventh advantage, defense or military applications. Military, please write military application. Military application. Military application. Military applications. Many times you would have seen Indian Army conducting of operations across the country or outside the country. Correct. So Indian Army is known to have conducted a lot of military operations over other countries also, like Mauritius, Maldives, Bangladesh, Sri Lanka. Correct. Like this. So Indian Army and Navy and Air Force have been sent to different parts of the world also. So they need latitude and longitude. So this topic is studied by everyone. Okay. Defense personnel, they also know this. Military personnel, they all know this. Okay. So geography students, we also know about latitude, longitude now. So let's say we are launching a missile. Let's say we are launching a missile from India on China here. See, from India to China here. So if you know the target's latitude longitude is very important. So the missile will exactly reach the target based on the latitude and longitude. It can be guided to the target using the satellite or the aeroplane. We call them as guided missile. How many of you heard of guided missile? Guided missile. We can guide the missile to the target based on its latitude and longitude with the help of a satellite or a aeroplane. So we call such missiles as guided missile. Okay. Today we have something called fire and forget. Fire and forget kind of missile. So even they work on the basis of latitude and longitude. So you fix the target. Okay. Feed the latitude longitude. We can fire the missile and forget it. So it will reach the target. So please remember this. So these are some of the applications of latitude longitude. Now all of you should be curious to know more about this topic because there are so many applications here. Okay, so sometimes you would have noticed you would have ordered the food in Swiggy, correct, or Zomato. You would have ordered the food and you'll be waiting for your food. So you would have seen that the delivery guy going from the going to the hotel, picking up your order, coming to your house. You can see the path, right? How many of you have noticed? How many of you have waited for your food? Like he is driving around, coming to your place. Correct? He uses navigation. Okay, sometimes you would have booked a cab like Ola or Uber. So the cab guy will be coming to your location. He will know your location automatically. Correct? He'll come to your location and wait for you. And when you go from one place to another place, you can trace the path where he is driving, how the destination, how you're reaching the destination. Estimated time and all will come to me. Correct. So we can integrate various applications here. For example, traffic we can integrate. Today there is traffic, let's say. So that also is added to the time part. So today there is more traffic, so more time is taken, like that. So we can give the real-time information to the people using this latitude and longitudes. How many of you are able to understand what I'm saying? So I've given you some practical examples like Zomato and Swiggy. I've given you the Uber and Ola. Correct? They are using also the same concept. Okay. When we use navigation, also we are using the latitude longitude concept. Okay. So please remember, now you should be very curious enough to know what's happening. What's happening? Okay. So latitudes and longitudes, all of you know the applications. Please remember this. So they'll ask you this in the interview, UPSC interview. They have asked, what are the various applications of latitude and longitudes? Okay. So please remember, these are the 7 most important advantages. So how many of you heard of this? Whenever there is a plane crash or a shipwreck, we can go there and rescue the people. If you know the latitude and longitude. Let's talk about the plane crash. So whenever the plane crashes, there is something called black box. How many of you heard of this black box? So the black box will transmit a signal. Okay, the latitude and longitude will know. With the help of that latitude longitude, we can go there quickly. We can rescue the people. And we can save people. Okay. So remember this. So rescue operations. So how many times you would have seen the helicopter comes up and picks up the people from the rooftop, which is flooded. People are flooded they're in a flooded area. The helicopter comes and saves the people. So the latitude and longitude help us to pinpoint the location, and you can send it to the rescuers. So they'll come in helicopters and save the people. So like this, you would have seen all this. So practically, we can utilize this. Okay. So many times in WhatsApp, you would have sent the location to your friends. Oh, send me the live location. I'll send you the live location. So you'll send the live location and you'll wait for them. Correct? You would have done that many times. So all that is based on latitude and longitude. If you have not done this latitude and longitude, we can't use that application. See the number of applications we have. Okay. So with the help of this, we can locate any place. Okay. So now all of you know what is the applications of latitude and longitude. So can I remove this now? All of you have written it down, or you can take a screenshot. Can I erase all this, friends? So this topic sounds interesting, correct? It sounds very interesting. So there are so many things that we can explore in this chapter. So next time you pay attention when you use your Zomato or Swiggy or Ola or Uber, what's happening there, you just check out. There'll be some numbers visible. Okay, some 5, 6 degrees, 7, 8 minutes, some minutes numbers will be there. So just check out what those are. Now, so let's go to the next slide. So two important lines here are equator and axis of rotation. So what is equator? Remember, we have discussed this. Equator is the circle, imaginary circle, which divides Earth into two equal halves. Please see this. All of you know this. So this red line here is equator. So equator is a circle which divides Earth into two equal halves. This one. I'm talking about this line. All of you are able to see this? This is the imaginary circle we have drawn. Imaginary circle we have drawn. This circle divides the Earth into two parts. This is northern hemisphere. This is southern hemisphere. Okay. So please write this. So all of you know the directions. North, south, east, west. All of you know this. So this is northern part, this southern part. So please write the definition. Equator is an imaginary circle. Equator is a circle which divides Earth into two equal halves. Which divides Earth into two equal halves. Okay, two equal halves. Two equal halves. So please remember this. Equator is a circle which divides Earth into two equal halves. It is the imaginary line. Okay, there is nothing called equator here, but we are imagining it. See the word equator. It is equally dividing the Earth into northern hemisphere and southern hemisphere. This is northern hemisphere. This is southern hemisphere. Already we have discussed in the previous topic. Next is axis. See, this is axis of the Earth. Here, this is axis. Axis is the imaginary line around which the Earth rotates or spins. The Earth is spinning around the axis. So you take a potato, put a pin, put a stick to it, through it, and notice the potato can be rotated around that stick. We can rotate the potato around that stick. Correct? You would have done that. Put a needle or the stick into it and rotate the potato. So potato is rotating around that stick. Just like that, here the axis is the line, imaginary line, around which the Earth rotates from west to east. West to east. Okay. So all of you, please remember this. Very, very important. So all of you got the words axis and equator? So I told you latitudes and longitudes are imaginary line. They give us angular measurements on the Earth's surface. So latitudes are always first one. We'll take the first one. Latitudes are measured always north or south of equator. Please write the third point. Latitudes are measured north or south of equator. Okay, north or south of equator. If this is equator, to the north is this, to the south is this. So they give us what? These two give us angular measurements on the Earth's surface. Angular measurements on the Earth's surface. So already I've told you North Pole, South Pole, fixed points. Geographic north, geographic south are fixed points. Okay. Why it is pole? Already I've given you the information. I want you to remember. Polar is star. So North Pole, South Pole, how they got the name also I've told you. Hope all of you remember that. Why North Pole? Why South Pole? So please write, latitudes are measured north and south of equator, whereas longitudes are measured east or west. Okay. So just remember, longitudes are measured east or west. Latitudes are measured north or south. North or south. So please remember this. First one is latitude. Give the heading as latitude now. Let's cover this first. Let's cover this first one, latitudes. So latitudes are angular measurement. They give us angular measurement of a place with respect to the center of the earth. Okay. Latitudes are, please write. All of you write series diagram. Latitudes give us angular measurement of a place with respect to the center of the earth. This is center. Let's say you have an apple. You cut the apple. You cut the apple. You'll get the seeds. That is center. Center of the apple. Just like you have center of the earth. With reference to the center of the earth and equator, with reference to the equator and the center, we can measure the point here. So all of you notice this point, please. Can all of you see this dot, purple dot? I'm calling it as A. This purple dot here is forming some angle with the center of the earth. This center. This is equator. So notice that the equator and center is the reference. Equator and center of the earth is taken as the same plane. Since equator is in the same plane with the center, it is called as 0 degree. How many of you got it? Equator is called as 0 degree because equator is in the same plane with the center of the earth. Agree? Yes. It's in the same plane. Same plane. That is equator. So notice that this point A is in some angle with respect to the center. That is 30 degree, approximately 30 degree. So this becomes 30 degree north. 30 degree north. Please do not write anything on the screen. Okay, notice this. All of you got it? Why it is called as 30 degree north? Because it is in northern hemisphere. Okay, north of equator. Plus, it is forming 30 degree with respect to the center. How many of you are able to understand this? I'll take another point B. I'll take another point B. 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 This point B. 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 So notice that B is forming 45 degree, let's say. It is forming 45 degree here. 45 degree north. Okay, now I'll take another C. C is forming, C is here. C is forming, okay, this center here. Now notice that the C is forming 90 degree. 90 degree. So it is 90 degree north. How many of you agree? Notice that C is perpendicular to the center. The point C is perpendicular to the center. Point C is perpendicular to the center. So what is latitude? Latitude is the angle formed by a place with respect to the center of the earth and equator. Please write. Latitude, all of you write, latitude is a angle formed by a place, by any place on the earth's surface, on the earth's surface, on the earth's surface. All this is in my book, Just Pure. This photo is from my book, volume 1. You can check it out. Just Pure, volume 1. Okay. Please complete the definition. Latitude is the angle formed by a place on the earth's surface with respect to the center of the earth. With respect to the center of the earth. Latitudes are always measured. Please write. They are always measured north and south of equator. latitudes are always measured. Latitudes are always measured north or south of equator. South of equator. North or south of equator. So is it clear to all of you? Please tell me if you have any doubt. So based on that, I have measured, see, so many angles I have measured. From 0 degree, all of you check it out, please. Check it out here, please. See this one, 0 degrees equator. See this, 0, 10, 20, 30, 40, 50, 60, 70. All these places are in different angle with the center of the earth. How many of you agree? Okay, I already written here. You have to pay attention. The simple maths here, simple geometry. What is geometry? How many of you heard of this geometry word? See the word geo here. Means like earth. Metry is measurement. So measurements made on earth is geometry. Actually, that's how it started. That's how the concept of geometry was started in ancient Greeks. The ancient Greeks and Romans, when they gave a term geometry, it was actually they were measuring the earth actually. Okay, they were measuring the latitudes and longitudes actually. That's how the word geometry. Okay. So latitude is the angle found by any place. See, A is one place, B is another place, C is another place, equator is on another place. They are forming different angle with the center. Okay, whatever angle they form, that is given to this latitude. So latitude is the angle found by any place on earth with respect to the center and the equator. Center and the equator. So this is 10 degree. Please note this 10 degree. 10. This is 20 degree. 30 degree. 40 degree. 50. You draw a line. Okay. 60. 70. 80. See? 90. 90. Is it clear to all of you? So notice this point now. The point next to 10 degree here. So point, see this 10 degree next to 10 degree. Even these points are also forming 10 degree. Please notice even this point is also forming 10 degree here. With respect to the center, even these points are also forming 10 degree. I'm crossing them. See these points. So can I connect them with a line and call them all as 10 degree? Even these points are forming 20 degree here. 20 degree. 20 degree. If they are forming same angle with respect to the center, I can connect them with a line like this. I can connect them with a line. Okay, this is around 30 degree here. All the points next to the latitude, they are forming same angle with the center. So we can connect them with a line and we can call them as parallels. What are parallels? Parallels are lines of same latitude. Parallels are lines of same latitude. How many of you understood this? Same latitude. Same latitude. That is, you can see this 40 degree. Okay, this is all forming 40 degree with the center. All of them are same. So I can connect them with a line because they all form 40 degree with the center. This is all forming 50 degree with the center. 60 degree with the center. Okay, 70 degree with the center. So on, up to 90. Up to 90. So if they ask you how many latitudes can be marked, how many latitudes can be marked on the earth, I'll say starting from 0. 0 degree is 1. Okay, 0 degree is 1 latitude. From 0 up to 90. 1, 2, 3, 4, 5, 6 up to 90. 90 here. Plus in the southern hemisphere also 90. If it is southern hemisphere, I'll write south here. 90. Overall, 90 plus 90 plus 1. Okay. 90 plus 90 plus 1 is 181. 181 latitudes can be drawn. 181. 181 Varun. Okay. 181. All of you got this? Equator is 1. To the north is 90. To the south is 90. Overall, it is 181. Overall, it is 181. Okay, please, equator is also should be considered. Equator should also be considered as 0 degrees. 1 equator is also a latitude, which is in same plane with the center. Equator is also a latitude because it is in the same plane with the center. We are taking it as 0 degree. 0 is also a number. Please don't forget that. Okay, 0 degree is also a number and it is in the same plane with the center. So 0 degree, 1. Plus to the north 90 plus south 90. 90 plus 90, 180 plus 1, 181. Okay. All of you got this? How many latitudes are there on the earth with a degree spacing? With a degree spacing, with 1 degree spacing, we have 181. So what are parallels? Parallels are basically lines of same latitude. All of you see this? See, I'm marking the latitudes and parallels for you now. See how it looks. See the right corner. Latitudes are measured with respect to the center. Allah. It is measured with respect to the center, to the equator and all the other parts of the earth. You can see this angle measurement. All of you know the angular measurements. Okay. Like this, angular measurements, all of you know. So whatever is the angle, we mark it. If they're the same angle, we connect it with a line. So what are latitudes? Latitudes are angle formed by a point on the Earth's surface with respect to the center. So what are parallels? Basically, parallels are lines of same latitude. Lines of same latitude are called as parallels. So equator is one parallel. 1 degree, 2 degree, 3 degree, up to 89 I can do. 89 north, 89 south. Okay, remember that. Because 90 and 90 are just points. 90 and 90 are just single points. These are single points. Okay, here. But rest of them are all parallels. Yes. So the average distance, notice that the distance between them increases as we go towards poles. Here the distance, see, notice the distance here. Since equator is, or since Earth is geoid, all of you remember geoid? Geoid. Earth is like this. Like this. Is all of you notice this diagram I'm writing? Here it is bulged. Bulge here. Here. The distance between the latitudes will be less here. But as I go northwards, the distance between the parallels or latitudes will increase. How many of you notice this? Near equator, the distance between the two parallels will be less. But as I go towards north, it increases because of the curvature. Remember, Earth is not flat like this. It is like curved. Bulged at the equator, flattened at the poles. As a result, as we go northwards towards North Pole and South Pole, notice this carefully. See this? 30 to 45 degree distance you take. 45 to 60 you take. It is increasing here. Notice this. Notice the distance of curvature here. How many of you are able to notice this A here? Compare that with B here. Is it same? No. The distance between the parallels increase as we go towards poles. Notice C. C is more than these two. Okay. So distance between the parallels increase as we go from equator to the poles. Remember this always. Okay. The distance between the parallels progressively increase as we go towards poles and North Pole or South Pole. So average distance is 69 miles. Please write the average distance between two parallels, let's say 0 degree and 1 degree, 1 degree, 2 degree. We can take the average distance as 69 miles. Please write the average distance is 69 miles between any two parallels. I'm just taking this as an example. Between any two parallels, what is the average distance? 69 miles. So please write this down. Shall I go to the next topic, friends? Hope all of you have understood latitudes and parallels. So what are latitude? Is the angle. So now all of you do one thing. So you sit in the center of your room. You sit in the center of the room. You will be the center. Okay. Your head is the reference. Your head is the reference. Okay. You are in the center of the room. Okay. Shall I do this experiment? Shall we do this experiment? Okay. You have to sit in the center of the room. Okay. You have to stand. You have to stand. Okay. Let's say your head is the center. Okay. You're exactly to the top. The ceiling will be 90° north. Your foot will be 90° south. Your foot on the ground is 90° south. Agree? So raise your hand like this. Raise your hand like this. That is equator. Okay. Raise your hand. Raise your hand exactly parallel to the shoulder. Okay. So that is equator. So notice that different parts of the room are in different angle to the center. That is your head. How many of you agree? You can lift your hand like this. You can lift your hand like this. You can see the angle formed by different parts of your room with respect to you, with respect to your head. How will you do? How many of you will do this? Okay, just do that once. Okay, that place is 70°. That is the latitude. The angle formed by that corner. Okay, it is a 70° angle. Okay, I'm saying 70. Okay, that is the angle formed by that place. That is the latitude. So all the points there are 70° now. This point. So that is parallel. So easy, right? You can do this experiment in your room. If you were in the class, I would have done this. If you were in the campus, if you were in a classroom, I would have done this experiment with you. We could have done that in the middle of the classroom. It would have been very fun. Okay. But now we can't do anything. You have to do this in your home. Okay. Please do this. So latitude is the angle formed by a place with respect to the center, and lines of same latitude is called as parallel. Let's see some very important parallels. There are some important parallels that you have to remember. Okay. Important parallels you have to remember. Let's write that. Okay. Notice this important parallels. So I'm writing the first one, equator. 0°. Reference with center. All of you know. Equator is called as 0° because it is the same plane with the center. Next, Tropic of Cancer. Earth is tilted by 23.5. Remember, Earth is tilted. Now I'm taking the tilt also. Because Earth is tilted by 23.5, I'm taking 23.5° as a standard parallel. 23.5°. Whenever you write latitude, you always write the degree, then minutes. Okay, degrees are divided into minutes. Minutes are divided into seconds. Degree, minutes into seconds. Remember, 23°, 30 minutes north. Tropic of Cancer. Then Tropic of Capricorn, 23.5° south. Okay, because Earth is tilted, you are taking this two as standard parallel. Next, Arctic Circle. 66.5 degree north. Antarctic Circle, 66.5 degrees south. Okay. Then North Pole, South Pole. So these are called as standard parallels of latitude. Standard parallels of latitude. So please write this down quickly. So why are these parallels important? Because Earth is tilted by 23.5 degree. So all of you remember the tilt part, please. Earth is tilted by 23.5 degree. Because of that, we all know that because of the tilt, Sun remains between Tropic of Cancer and Tropic of Capricorn throughout the year. Okay. So what if there was no tilt? Think about it, friends. Always remember, Earth is tilted by 23.5 degree. I'm going to show you that. Give me 1 second. Notice this. Notice the tilt here. Earth is tilted by 23.5 degree. Okay. So what if there was no tilt? When there was no tilt, sun rays should be following exactly over the equator. How many of you agree? If there was no tilt, no, I'm not talking about rotation, Nandini. Nandini, you're confusing with rotation. I'm not saying about rotation. I'm talking about the tilt. If there was no tilt, the sun rays should be falling exactly on the equator. Because of the tilt, the sun rays are falling somewhere over here, Tropic of Cancer. Here, this is Tropic of Cancer here, this line. See, the sun rays are falling exactly here. Sun rays are falling here, Tropic of Cancer. Otherwise, if there was no tilt, sun rays would have been falling over the equator. So that's what I'm trying to say. So because of the tilt, we have sun rays falling different parts of the earth. So throughout the year, sun remains between Tropic of Cancer and Tropic of Capricorn throughout the year. So in the month of March, sun is here. See, I'm showing you March, sun is here. March 21st, sun is here over the equator. After March, April, May, June, sun comes to north here. Sun is here now. June 21st, sun was in northern hemisphere. June, July, August, September, sun will be here. September 23rd. Then after that, October, November, December 21st or 22nd. Okay. So please remember, after December, January, February, March. Okay. See this. After December, January, February, March. So I'm starting from December. December sun is here over 23.5 degrees south, southern hemisphere. After December, January, February, March, sun comes to equator. March, April, May, June, sun goes to northern hemisphere, Tropic of Cancer. July, August, September, sun comes to equator again. October, November, December, sun comes to southern hemisphere, Tropic of Capricorn. Like this. So throughout the year, sun remains between these two lines because of the tilt. How many of you understood? If there was no tilt, sun would have been over the equator throughout the year. Sun rays would be falling exactly equal over northern and southern hemisphere because sun rays would be over equator if there was no tilt. Since we have tilt, sun rays will be falling between these two lines. How much is the tilt? 23.5 degree north, 23.5 degree south. So remember this, friends. So that is the reason sun always remains between these two parallels. These two parallels. Okay, these two parallels. So these regions will receive a lot of energy, nearly 320 watt per meter square. What is watt? Unit of power. Watt is unit of power per square meter. 320 watt of energy is falling. So that is a lot of energy is falling here over the tropical belt, over this area. So it is called as tropical zone. How many of you heard of this word tropical? Why it is called as tropical? Tropical means hot, hot. In Sanskrit, it is Ushna, Ushna Valaya. Okay, tropical. Oh, sorry. 1 second, I'll write the spelling. Already I've written TROPICAL, tropical. Please write tropical. Tropical zone or torrid zone. Tropical or torrid zone from here to here. Tropical or torrid. Torrid here. So most of the sunrays will be falling in this belt, that belt. Hot, 320 watt. Watt is unit of power. Okay. What about the polar region? The polar region will be getting slant rays because sun is always between these two, Andre. If the sun is concentrating on this region, these regions will get vertical rays. But polar regions will get oblique rays. How many of you understand oblique? Oblique means slant rays. So the polar regions will receive less energy, less heat energy. 70 watt per meter square. 70 watt per meter square. 70 watt per meter square here and here. So this reason the polar region lacks heat. What is absence of heat? Please somebody tell me what is absence of heat. I have told you this in the first class. What is absence of heat? So some of the student is asking why is earth tilted? Santosh, already I have told you here. You have to pay attention. You have to come to the class every day. Okay. So I'm very shocked that some students are asking why and how earth is tilted. So already we have discussed this, right? If you're asking the same question again, it will spoil the momentum of the class. Okay. So I request you to revise when you come to the class. We have covered this topic. Why there is tilt and all. Remember, I showed you the documentary. We discussed it twice in 2 classes. Okay. So please see, 70 watt per meter square is the region where we will be receiving less energy. Absence of heat is cold. Remember, what is absence of heat? Cold. That is the reason the polar regions are frigid. Polar regions are frigid. Frigid. The polar regions are called as frigid zone. How many of you heard this word frigid? Means very cold. Very cold. Cold. So polar regions are cold, frigid. Okay. So please remember. So already I've told you why Earth is tilted. I told you about the asteroid impact. Tia asteroid impact led to the tilt. Already I've given the explanation and I'm repeating again. The tilt of the Earth is because of the asteroid impact. So frigid and polar. That is the reason the polar regions contain ice. Okay, frozen water. The water is frozen in the polar regions. What about this area here? This area here, temperate. Neither too cold nor too hot. Neither it is too cold, so it is temperate. Temperate. Please write. Temperate means moderate. How many of you heard of this word temperate? Temperate. So what are the 3 climatic zones of the Earth? The 3 climatic zones of the Earth are tropical or torrid, temperate, polar. So remember, these are 3 climatic zones of the Earth, major climatic zones of the Earth. So all of you remember this. This 0 degree, this 23.5, 23.5 degrees south. Okay, I'll take another belt, 30 degree. I'm taking 30 degree now. All of you see this? 30 degree. 30 degree, 30 degree. 30 degree, 30 degree. This is 30 degree north, 30 degree south. So this belt is also bit hot, correct? Because close to the tropical. So this is called a subtropical region. How many of you heard of this word subtropical? Subtropical. So 23 to 30 is called as 23.5 to 30 is called as subtropical. Please write. The region between 23.5 degree north to 30 degree north. Similarly, 23.5 degrees south to 30 degrees south is called as subtropical. 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 Rajasthan is in subtropical, Chetana. Rajasthan is subtropical. It comes in 23 to 30. Check it out. Check it out. Okay. Because when sun comes, it becomes very hot. Okay. So don't worry. I'll give you the explanation about Aravalis in Rajasthan, leeward side of Aravalis, and all this concept is still pending. We have to discuss that. You'll understand slowly. Okay. So this topic is very important. Latitudes we have covered. I'm going to apply that tomorrow. In tomorrow's class, we are going to do the application. Okay, don't worry. So till then, please remember, friends, we have covered a very important topic. So if you want, you can take the screenshot. Screenshot. We'll continue this tomorrow. Is it clear? Because I can't continue more than 1 hour. So as a result, I am stopping now. Tomorrow's class, I'm going to extend. Okay, continue the same topic. Okay, don't worry. Thank you very much. Hope all of you have understood this topic. Very easy, bit mathematical, correct? Bit mathematical. Okay, thank you. Thank you very much. Thank you.